Alright guys, we're going to explore the laws of exponents. Alright, key questions. What are the laws of exponents and how do I use them to simplify expressions? So we're going to start out with a product rule. So we're going to complete this table and then answer a few questions about it. So as you can see right up here, the first one is 3 to the power of 2 times 3 to the power of 5. And we expand that form. As you can see, they did color coding here, the 2 blue ones, and then you had 5 red ones. So that gave a total of 7 3's being multiplied together. So that's the same thing as saying 3 to the 7th power. So let's do that with the 2's. We have 2 times 2 to the 6th. Well, this first 2 has got a power of 1 right there. So we got 1, 2, and then we have 6 more because it's 2 to the 6th power. So 1, 2, 3, 4, 5, 6. So that gives us all together, that should give us 7. 2 to the 7th power. Now let's look at our b to the 5th times b to the 8th. So we're going to have 5 b's. 1, 2, 3, 4, 5. And then we have b to the 8th. So 8 b's. 1, 2, 3, 5, 6, 7, 8. So now this should give us, if we take 5 plus 8, that should give us 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have b to the 13th power. Look at the table below. Compare the first and third column. Describe your words' relationship that you see between them. We'll say to multiply powers with the same base, you need to add the exponents. Okay, so number 2, use your observations from the previous question to fill in the box and complete the math sentence below. So we have a to the m times a to the n. Therefore, we're going to take m plus n. The rule you discovered in the question above is called the product rule. Use it to simplify the expressions below. So as we know, when we multiply these together, we need to add the exponents. So 2 to the 6th times 2 to the 8th, that should give us 2, and we're going to add 6 plus 8. So that's going to give us 2 to the 14th. Alright, now we've got negative 7 to the 3rd, negative 7 to the 1, power of 1 there, times negative 7 to the power of 5th. Alright, so we're going to take negative 7 for sure, and we're going to add those exponents. So 3 plus 1 plus 5. That's going to give us negative 7 to the 9th. On part C, we have m to the 1st power times m to the 5th times m to the 6th. So we're going to take m to 1 plus 5 plus 6. And that should give us m to the 12th. Okay, let me put boxes around these guys. Alright, so that's the product rule. So now we're going to move into the power rule. On this first one, 5 raised to the power of 2, which all that is raised to the power of 3. So we have 5 times 5, which is 5 squared, times 5 times 5, is 5 squared, times 5 times 5. So we have 3 groups of 5 squared. And as you can see here, when we multiply them together, what do we do on the previous one? We added the exponents, right? So that should give us 1, 2, 3, 4, 5, 6. 6. So 5 to the 6th power. So now we should have, on our 8s, we got 8 to the 5th, which is all raised to the power of 4. We have 4 groups of 5/8, okay? And if you're going to count those all up, how many should you get? Well, you should get 20, right? These, and you can add them all up, just like we did on the previous one, right? Well, what else could we do besides just adding? Isn't 5 times 4, isn't that 20? Isn't 2 times 3, isn't that 6? So we can multiply them. When you have an exponent raised to another power, you can multiply them together. So in this one, for x cubed raised to the 4th power, we should get x to the 12th. Okay, so we have 4 groups of 3 x's, which gave us 12 total x's. So compare these, and what do we find out? What's the relationship? So to simplify the expression, keep the base the same and multiply the 2 exponents. Again, to simplify the expression, keep the base the same and multiply the 2 exponents. Now let's use observation from the previous question to fill in the box. So we have a to the m raised to the nth power. So again, that is simply going to be a to the m times n. The rule you discovered is called the power rule. So it's called the power rule when you have an exponent raised to another exponent or another power. You simplify the expressions. So if we have 7 to the 4th raised to the 9th, we're simply going to take 4 times 9, which should give us 7 to the 36th. Now we have k to the 17th power, all raised to the 2nd power. So we should get k to the 34th. And then we have w to the 100th power raised to the 20th. So we should get 100 times 20, which is 2,000. So w to the 2,000th power. Let's go ahead and box these. Alright, so now we move on to the quotient rule. So on the quotient rule, you take 6 to the 9th divided by 6 to the 4th. I have them listed out here, and as you can see, they can cancel each other out, just like we've done simplifying other equations, right? If the same number is on the numerator and the denominator, they can cancel each other out. In which case, it left us in this with the 6's, just left us with 5 of them, so 6 to the 5th power. So now we have 100 to the 3rd divided by 100 to the 2nd. Well, 100 over 100 is 1. 100 over 100 is 1. So we're just left with a single 100 on the numerator. So 100 is your answer. Now we got t to the 15th over t to the 11th. Alright, so if we got that 15 t's on top and 11 on the bottom, let's see what crosses out. So we're left with, on top, we have 1, 2, 3, 4. So we have 4 t's on the top, so a t to the 4th. So how are we going to do this? What can we compare, or how do we describe? So how do we describe the relationship between, so now we can describe the relationship that you see between them. So if you divide with the same base, if you divide with the same base, subtract the exponent of the denominator from the exponent of the term in the numerator. So if we have a to the m divided by a to the n, we are simply taking a to the m minus n. So let's work these 3 problems like this down below. Part A, 16 to the 7th divided by 16 to the 3rd. So that's going to be 16, 7 minus 3, which is going to give us 16, the 4th power. 1 over w to the 10th times w to the 25th. And don't let that confuse you. Everything you see like this is always over the number 1. So you can just multiply across. So that really is w to the 25th over w to the 10th. So we're taking w to the 25th minus 10, which gives us w to the 15th. For part C, we have 4 to the 3rd times 4 to the 7th divided by 4 to the 5th. Well, if you remember, if we have them multiplied, we're taking 3 plus 7 all over 4 to the 5th. So on top, this is going to give us 4 to the 10th all over 4 to the 5th. So then we're going to subtract them. 4 to the 10th minus 5, which gives us 4 to the 5th power. Alright, so now we're going to do power of a product. So with this first expression, it's 2 times 5 in parentheses raised to the 3rd power. In which case they took 2 times 5 times 2 times 5 times 2 times 5, which equals out to 2 times 2 times 2 times 5 times 5 times 5. So that gives us 2 to the 3rd times 5 to the 3rd. So they just distributed this power of 3 into each component inside of the parentheses. So if we have this with a 3x raised to the 4th, that's the same thing as saying you have. So we have 3 to the 4th times x to the 4th. Okay? Now, for this next one, 7 squared, y cubed, z to the 4th, all raised to the power of 2. Well, we're going to get 7 to the 4th, y y to the 6th, and z to the 8th. So what do we do with this? Well, when raising it product to a power, you multiply the power by the exponent of the term and leave the base the same. Alright. So what do we observe from this? Well, we have x times y all raised to the b power. You're simply saying you have x to the b times y to the b. So you're distributing that exponent inside the parentheses. So let's work this out on the next problem. So a, 3 times 5 to the 7th. So we're simply saying we have 3 to the 7th times 5 to the 7th. We have 17 times w, all raised to the 2nd power. So you could say this is going to be 17 squared times w squared. 2a cubed times b to the 10th, I'll raise the 9th power. Well, you're going to have 2 to the 9th, a to the 27th, and b to the 90th. Because you're multiplying this exponent times each power inside the parentheses. All right, our last power rule here. So, power O quotient. So if we have 3 over 5, I'll raise to the second power. Well, that's like taking 3/5 times 3/5, which is 2 3's on top, 2 5's on bottom, which is usually 3 squared over 5 squared. So you're distributing it to the numerator and denominator for this. So with our m over 8 to the 8th, all right, so we have 4 m's on top and 4 8's on the bottom. Now we have a negative a over 9 squared. So we have a negative times a negative. So that's going to give us negative a times negative a all over 9 times 9. So negative times negative is a positive, so we have a squared over 81. We're going to multiply the exponent of each term by the power. So multiply the exponent of each term by the power. So as we saw in our observation here, x divided by y raised to the power of a is attributing that a in to the x and the y. So we have x to the a and y to the a. Now if we have, so we have x to the a divided by y to the a. The law discovered in the question above is the power of the quotient. So use it to explain the problems below. So we should have here distributed in there. So we get 5 to the third divided by 4 to the third, which gives us, same thing saying 125 over 64. On part B, we got 2x divided by y to the 7th. So you've got 2 to the 7th times x to the 7th, all divided by y to the 7th. And then on part C, we got negative a over b raised to the power of 8. Well, since that's an even power that is raised to, therefore that negative is going to turn positive. So if we raise to a positive power like this, it's going to change a negative to a positive. So we have positive a to the 8th divided by b to the 8th. Alright guys, so we've gone over quite a few about the laws of exponents. Hope you learned a little something today, and I'll see you next time.